All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to continue learning about async programming for the ESP32 using the Embassy framework. Holy shit, dude! I've made a ton of progress in terms of the when it comes to the content pipeline, version 0.5. Give me a second here. I just need to, I guess here I can open up this thing. Yeah. Um, what was I saying? Yeah, I've been making a ton of progress. So there were two sides where I had to build stuff or work on stuff. One side was setting up the prompt to give the best possible quality of output, because Gemini is the one that's analyzing the workflow, the new workflow that I came up with for content pipeline version 0.5, as opposed to version 1, which is what I've paused the development for that right now. That's going to be a much more sophisticated system. For the time being, I've paused the development on that because there's a bunch of, let's say, prerequisites that I haven't satisfied yet, and if I keep waiting to satisfy them, then in the meantime, I'm just not going to have any content to I'm not going to have any content being produced, and I'm not going to have anything to post. So just to kind of get the ball rolling, so to speak, I wanted to come up with the quickest solution that I could find. So the quickest solution I could find was I'll feed my YouTube video, just pass the link basically. I'll feed the YouTube video into Gemini as a prompt, and I'll say, okay, analyze the transcript for this video. And then I have some instructions for you. And further from that point, what I do is, hold on, I can show it here. I actually don't have the prompt. I mean, I have the older prompt, and I've shown what that prompt is supposed to be, um, what that prompt is supposed to look like, but I do not have the newer prompt. I don't know how. Okay, wait. By the way, another great thing that two things actually. So I've been using FZF. It's a fuzzy finder application, which has integration with various types of integrations with your shell. You can also use it as, like, a standalone application, but using it with other applications, it is incredibly helpful because this tool can find things super quickly, and being able to integrate this with other stuff, it makes it like a bonus sort of situation. So let's, as an example, let's say I do bat, okay, and then um, say I do bat, and then I do um, hold on, do I not have it here? Sorry, I'm trying to show the I'm trying to show the FZF integration here, but that doesn't seem to be working. Give me a second. So there's two things that I want to show. One is this double asterisk thing, which I just realized you guys cannot see. Let me bring it down here. Now you can see it. Okay, so there's this double asterisk thing, which it's integrated with various, what do you call it? Oh, yeah, yeah. Sorry. It's integrated with various tools. So if you are trying to open up, let's say, something with NeoVim, and then you type, I don't know, something like this, then it should show you a bunch of things, pretty much like this. So I'll type, for example, um, I'll type P, because within this directory, I know that, there's a bunch of stuff. Let me, yeah, even within like the subdirectory, even within the subdirectories, there's a bunch of things. So I can type neovim and then P and then this. So I'll do double asterisk and then I'll hit tab, and then you can see the FZF menu opens up here, and it has already typed P, and it's going to display, whatever results it finds. And then I can narrow down my result and bring it here. And if I hit enter, now it's going to open the thing. Another thing I learned is that, and this was there just like part of the default configuration, part of the default settings. If I hit Alt C when I'm within a certain directory, then FZF is going to search for all the subdirectories within that directory, and I can choose to CD into any of those directories. So let's say I want to CD into imports. Now I'm within imports. This is amazing. This is great. This is in addition to the other two commands that we have. One is Control T to just fire up FZF within the current directory. The other is Control R for your list of previously typed in commands. This is your, I forgot what you call it, command history, basically. So you can revisit your command history. Let's say I want to do tmux ls. I can just hit enter and it types that out for me, and then I hit enter again, and now there's the result. So this is great. I discovered this yesterday, specifically the Alt C and the what do you call it? And the double asterisk tab thing. The thing is, I had actually found out about the double asterisk thing a while back, but for some reason I wasn't able to get it to work. It took me some time to realize that FZF has created this as they've created this as an integration for various commonly used applications. So NeoVim is one of them. BAT is another one of them. So like, let's say I CD back here and I want to do, actually, let me CD into Scratch stuff. I think I have Scratch stuff here. Yeah. This is great, dude. Zoxide interactive feature is amazing. There's so many shortcuts that I've managed to set up uh, thanks to these applications that it's insane. It has improved my workflow big time. Not having to remember a bunch of paths, not having to constantly type out, extra long paths here and there. Like, imagine if I want to jump into some other directory, I can very easily jump using this, and I don't have to like even scroll down. There's a search menu, so I can type, let's say, trunk to go into the SRS trunk folder, SRS trunk directory. If I want to go back here, I can just do this. That's holy shit, dude. This is crazy. Okay, back to what I was talking about. I actually wanted to go into empty directory. I just remembered that. So in empty directory, let's say I try to do bat. I wonder if I can do it this way. Yeah, I can. So I can do it without typing any characters either. So in here now it's listing all of the files that are there. I don't know if it also lists directories or if it's just files. No, it lists directories as well. Okay. Well, actually, okay. Oh, wait, I was about to say that no, NeoVim can open directories as well, but we are not in NeoVim. We are in BAT. I wonder what that's going to look like. No, it's going to give an error. Okay, okay. But yeah, that's one of the integrations that we have as well. There's a set number of command line utilities and maybe even TUI applications that that FZF has integration for. And I didn't even have to do anything special. I just had to like allow it to set up its default integrations. So when you install the thing, there's an install script, I believe, that you have to run. When you run that script, it does whatever, file replacing and stuff it has to do. Additionally, it also checks your bash RC file for specific lines that it is looking for. And that's how you add, FZF integration in there. There's even more additional integration. There's even more customization that you can do to the shell integration. After exploring that for a bit, I realized that I don't really want to go too deep into that because that requires a it requires a bit of understanding of how FZF and how shell related scripting works. And to be honest, I didn't want to go too deep into that because that was going to take time away from the other stuff that I was doing. So, I mean, FZF's default integration works just great for me. Like we've got the Alt C, we've got the Control T, we've got Control R. We've also got, what was the other one? Oh yeah, the double asterisk thing. Oh, don't do that. Hold on. That's interesting. That is, wait a minute. What did that just open? It opened 23 buffers. Okay, so I made this mistake, right? I accidentally left. What I meant to do was this, and then in here I would do something like, let's open up Scratch. Where's Scratch? Let's open up Scratch '03. Okay, and then we'll save this and quit. And then the next time I open this up, yeah, there we go. So I don't want the thing opening, all of them. But I didn't realize that this would actually, does this also do it? This also does it. That's crazy. Okay, I just learned something. So this is how you can open up all the files. So you can open up NeoVim within a directory and also open up all the files as buffers. So if I look at, wait, what was the way to do that? This, okay. So this is the entire list of buffers that's open. Yep, yep. This is the entire list of buffers that's open right now. But yeah, let's close this because I don't mean to do that. We'll open this and I want to open up Scratch '03, save it, go back, and real quick, let's open and make sure that that's the only thing that shows up. That's the only thing that shows up. Okay, we're good. Back to what I was saying. Yeah, I recently learned about the Alt C and the double asterisk tab thing. So that was great. I still have to make that set of videos of the various terminal based tools that I use because I have a very heavily terminal based workflow at this point. So it kind of makes sense for me to make a video on all the tools that I use. Um, yeah, dude. I have like an entire list here. Let me come up here. Yeah, this is my entire list. In fact, I'm seeing in FCF I set something up here. Um, export FZF default command for FD. I don't remember why I added these in. Okay, FZF default command. This. Okay, I'm gonna have to look into this because I don't remember why I have this. I don't remember why I have this. Why I have these two things in there. I can't remember if the Control T thing was like an automatic thing or if they had it mentioned in the repo or if there was something else. I believe this is supposed to be default, but then at the same time I don't remember. Oh, hold on. I have it on another machine. Um, you know what? In the future, if I ever need to set the thing up, Uh, After I run the git install, usually it asks for for the shell integrations. Like if I want to set up shell integrations, set up key bindings, and maybe one or two other things. After I've set that up, I can come back here and like compare this with my bash rc and see if it's there or not. If it's not there, then I can, do something about that. But yeah, I've been busy working on the application that is here. I made some good progress. Definitely made some good progress. There's this function here for sanitizing the name, the title name. So within the manifest, I also asked Gemini to generate a title for each clip that it's coming up with, and so each clip's title looks like this. The thing is, I can't necessarily always set this as a file name. There might be certain characters that I you know can't enter as a file name. And additionally, I also don't necessarily like putting spaces in my file names. It kind of complicates things a little bit. So wherever possible, I try to turn the space into a hyphen or an underscore. And in terms of file names, I also often prefer to have like lowercase. And there's libraries out there that do that for you. Um, I could have used one of those, but for the time being, because I wanted to make this script as dependency free as possible, dependency free as in not dependent on external dependencies, but whatever the standard library is offering, I'm perfectly fine with using that. For the time being, I want to keep it as dependency free as possible, so I don't have to, enable or activate a Python environment each time I want to use this script. It makes things simpler. It keeps things simpler. So for the time being, what I'm doing is I'm essentially I've set up a file here called clip manifest. Ignore the clip manifest chunks. I've set up clip manifest, and this is what clip manifest looks like. It's basically just a JSON data. The JSON data is it's an array of these individual dictionaries, let's say, and this is what will then be read by this function, the loads function, and it'll be converted into, um, well, it won't be converted. It'll be stored into this clips object as a list of dictionaries. And then I iterate over the clips list, which is, individual dictionaries, and um, I can access the per clip properties, per clip fields. Yeah. So further from this point, what I need to do, what's supposed to happen is it's supposed to launch a, what do you call it? It's supposed to launch ffmpeg to, to run the, clip extraction process. And I have, through Gemini, I've got, hold on, maybe I can just copy this and paste it here. So far, this is what Gemini has come up with. Dude, when I tell you Gemini has been, actually, maybe I should create a scratch file here. Scratch oh 01. There. This is a command that Gemini has prepared for me, where I can specify the number of threads for the decoder and for the encoder, because I'm not, give me a second. I'm not going for the, what do you call it? I'm not going for the copying method, because in the copying method, the beginning and the end of the clip can end up having, what do you call it? can end up having either frozen frames for a couple of seconds or black screens for a couple of seconds. So to avoid that and any other possible issues that may arise, I decided to just re-encode the thing. The thing is to re-encode it and to properly access these frames. Not Gemini, FFmpeg is going to have to decode the frames first, and that could, take a little bit of time, depending on how long the video is and how far into the video you are trying to seek, because you have to like seek up to that point. You have to go up to that point within the video, and from there to whatever endpoint you have specified, it's then going to extract that entire thing. Give me a second here. There's something I need to close. Okay, done. Right. Um, for the decoding process, I wanted to be able to control the number of threads. For the encoding process, I wanted to be able to control the number of threads, because by default, FFmpeg and whatever other programs are running within it, if they are multi-threaded, they are going to use your CPU to the max of its abilities. And if that means that, it'll max out your CPU and like um, take the temperature up to 80, 90 degrees, it's going to do that. I've actually watched that happen. I don't know if that happens on Windows or if Windows has like better control over that, but at least on Linux, if the program can, it will absolutely use like a decent chunk um, of your CPU resources, unless you find a way to cap it. And that's why there's a bunch of programs that they allow you to specify a flag. Like, for example, in Cargo, whenever I'm doing cargo build, I usually set the number of jobs. So I give it like anywhere between 2 to 4 jobs, and that helps depending on which CPU I'm using, because I have multiple machines here and not all of them have the same hardware, not all of them have the same CPU. One of them has 8 logical cores and I think 4 physical cores, and the other has, I believe, 2 physical cores, or hold on. Yeah, this one I don't entirely know. This is a desktop one. I don't entirely know if it's 4 physical cores with 1 thread each, or if it's 2 physical cores with 2 threads each. Either way, what I have is 4 logical cores, so 4 threads. Um, and what I usually try to do, generally, a lot of these operations, they're not like massive operations. They're not like one massive operation that's happening. Fortunately, a lot of them are not one massive operation. They're usually broken down into much smaller chunks. So what I do is, if I know that I only have like 4 logical cores available, I'll set the number of jobs to 2, and so it kind of just bounces around between various cores. I'm not telling it which specific core to use. That's up to the kernel, and I think maybe to a certain extent, Cargo might be deciding something there. I don't know, but generally, it's up to the kernel scheduling system to decide how the jobs are distributed. Um, what I'm doing is taking advantage of that. The fact that if it's 2 jobs, let's say I have 4 cores, right? Cores 0 to 3. The first 2 jobs, they start executing on cores 0 and 1. And let's say core 0 is done. So the next job has to execute. The next job might execute on core 2 or 3. So what that does is that allows core 0 to cool down a little bit. And then whenever core 1 is done, then the next job will execute, and that could execute on um, one of the other free cores, whichever happens to be. And this is why it's useful for the kernel to just, in its own intelligent way, schedule the job for whichever core is ready. I'm sure if it's a cooler core, then the kernel is probably going to go for that one instead of the core that's much hotter. I should probably look into that, because that's my assumption, that the kernel is going to be clever enough to look at the temperature of the core and decide that, okay, maybe not on this core, maybe we'll go on one of the other cores. But this is generally how I'm able to distribute the work across the CPU. Actually, no, I'm not the one distributing it. It's already distributed. This is how I limit how many cores are actively doing the jobs at once. So the overall temperature of the CPU, because of this, it remains at a manageable rate. Things don't get insanely hot because at any given time, two cores are working while the other two cores are cooling down. And yeah, that's why I wanted to see if FFmpeg can also do that, and it turns out yes, it can. It has the option for that, and additionally, it has the option for both the decoder and for the encoder. So you can like customize those options. Um, yeah. So what I'm thinking is like, because a lot of times they're going to be smaller videos, so the encoding is generally for the output. It's going to be encoding the output video, right? The decoding is happening to whatever input you have given. So because the input video is going to be massive, so I'll give it two threads. And because I know that the output video is going to be pretty small, usually, anywhere from 30 seconds to a couple of minutes. So I can give it maybe 3 or 4 threads. So even if it's maxing out the CPU, it's only going to be for a couple of minutes and then it'll finish the job relatively quicker. But yeah, this is the command that, sorry, got distracted. This is the command that uh, Gemini has set up for me, and I'm going to be using this. I have to plug in some of the values. I have to do some test runs, is what I'm trying to say. In testing this out, so far, this is what I've got. So this is some of the output. You can see I also converted the time from seconds to a proper format that FFmpeg is expecting. Give me a second. Yeah, so I've converted it to a format that FFmpeg is expecting. So you can see on the left side it says the start time and then hyphen and then end time. So now all I have to do is run this run these timings through FFmpeg and get it to create these clips for me, and then I have to see what the quality is like. Speaking of quality, I just realized that I was supposed to jump into embassy stuff, but then I got distracted and started talking about this. Give me a second. Okay, all right. So, actually, give me give me one more second. I need to open my chat on my phone. Yeah, okay. Right. Now, one more thing that I was going to talk about, which I cannot remember what it was. What was I going to say? I was going to talk about the yeah, dude. I don't I can't remember what I was going to mention. Oh, yeah. So, in terms of quality, I noticed something with Gemini's output. I noticed something with Gemini's output. There was an issue where actually this might be a perfect example. So, if you notice here, if you look at the seconds, okay, this specific stream. It just so happened that this is one of my longer streams. So the stream ran for 3 to 3.5 hours long that day. I usually don't do, that long, but um, on that day I managed to start early and also run for that long, which was great. But the point is, it was a long stream. Um, and in a way, that was great because that became a good test bed for, you know, for this tool that I'm working on. So I asked Gemini to analyze the entire transcript, which means from the beginning all the way to the end, the entire like 3.5 hours. I didn't specify the time, but if Gemini looked at the entire transcript, it knows what the time is. Okay, and then I told Gemini, okay, analyze this entire script, and within this entire script, find clippable moments. Okay, and then I gave it like the criteria that it could be informative, educational, funny, or there was one more word I had mentioned. I can't remember, but yeah, there were four specific like categories that it could be under, and then in terms of timing, I said it can be anywhere between 30 seconds and 10 minutes. Okay, great. Um, what I noticed is, and I had a doubt that this would happen, but I didn't want to say anything until I tested the thing out. Um, what ended up happening is Gemini looked at the beginning and like it found like a massive amount of stuff at the beginning, and it looked at the end and it found a massive amount of stuff at the end. And so it just analyzed the majority of that. So as a result, you'll notice here it says 4 seconds, 126 seconds, 524, 625. So here we are going into like what, maybe 15 minutes, 20-minute mark, right? We are going into the thousands. I think that's still 20 minutes. Let's say 30 minutes. Okay, keep going, keep going, keep going. From 2,359, it jumped to 12,765. That is insane. I was like, okay, what happened to all the content in between? And so I told Gemini that I'm noticing that you have only looked at the beginning and the end of the stream. Not exactly beginning and end. I mean, to be fair towards Gemini, there's still like a, you know, good chunk that it did look at, even from the beginning, even from the end. It's not like super close to the beginning and the end, but the problem here is the point, and that's the problem, is that it kind of ignored the middle of the transcript. And I had a doubt that this would happen because in past research that I've done on LLMs, Gemini itself had told me that LLMs tend to have this tendency to, if you give them like massive text, they'll mainly look at the beginning and the end, and they'll leave out everything that's in the middle. Everything that's in between, it's just going to be left out. Um, and that seems to be what happened here because we are missing like what, 10,000 minutes. Actually, not even. Sorry, is that 10,000? Yeah, yeah, that's 10,000. We are missing 10,000 minutes. So that's 2,000 to 12,000 jump. And 10,000 minutes would be what? Hold on. Um, 10,000 minutes. No, 10,000 minutes. 10,000. No, I'm supposed to divide it. That's 166 minutes. 120 minutes is 120 minutes is 2 hours. And how are we getting to, so 40 minutes, 2 hours and 40 minutes worth of content is just missing. It hasn't been analyzed. And when I asked Gemini about this, then Gemini was like, yeah, I analyzed that and I found that there was a lot of dead air in between and all of that. Now, granted, yeah, there does tend to be dead air in between. Um, Even now, even in this stream, you will find it. But I found it hard to believe that Gemini could not find anything useful in those 2 hours, close to 2 hours. So what I did is I decided to divide up the prompt. I changed the prompt to, or I decided to divide up the analysis. I made it so I tell Gemini, give me a second here, just need to do something. Okay, so I told Gemini that so I would give Gemini the link of the video, and I would be like, analyze 0%, analyze from 0% to 25% of this transcript. And fortunately, Gemini understood what that meant, and Gemini only analyzed that much. It also mentioned that, okay, from 0% to 25% range, this is the timing that we are talking about. And then in the next prompt, I said, okay, now given the data that you have analyzed, go through this data and find clippable moments, and then just the usual, the next clippable prompt thing that I'd set up. And this time, it seems to have given better results. I have to look at the quality of the clips that are being produced from this, because in this way, I'm able to get Gemini to cover uh, the entire range. So what I do is I get it to analyze 0 to 25% of the transcript, and then do its thing with that. And then I get it to analyze 25% to 50% of the transcript, and then do its thing with that. Then 50% to 75%, do its thing with that. And finally 75% to 100%, and do its thing with that. Now my only work there would be to later on stitch all of this data together into this kind of data, because this JSON data that we are looking at, the reason that this works is because this is being presented as a list of dictionaries. Um, and with the prompt that I've created, Gemini would be producing 4 different lists. So all I have to do is make sure that I stitch them up properly, so that the Python script is able to read this entire JSON file properly, and it's able to, run the clipping process. Additionally, something that I could do is um I could get see what I wanted to do is I wanted to, like, extract all of these clips in one go, just so I have a bunch of the clips to, look at. But I'm wondering if I should make it so there's indices attached to each of these, and then I'll write another script where I can specify an index, and then the script is gonna read through this entire thing, pull out that specific index's clip, pull out whatever clip belongs to that specific index, and only extract that specific clip. But like, I feel like the first method would be better for now. It would be simpler. There's also the fact that um, I forgot what I was about to say there. But yeah, I need to these are 2 ways that I can go about it. Like, okay, I could read the caption, and that'll give me some idea of what the clip is going to sound like. But in general, just looking at this is not enough. I would want to actually see the clip. And the only way that I can, see the clip is if it has been extracted. Unless I want to go into my VOD and um, scroll to whatever the time is, and then look at the video in that way. I feel like this method would be a little faster. Oh, dude, you know what? Hold on. I just got an idea. There's 2 ways that I can go about this. So FFmpeg has the holy shit, dude. We are supposed to be doing embassy stuff. We are 40 minutes into the stream. We're supposed to be doing embassy stuff, dude. Shit, I forgot. Well, okay. Anyways, um, there's 2 ways that I can go about this. Okay. So when you're extracting the the how do how do I say this? Within FFmpeg, the extraction process is basically you call FFmpeg and then you specify a start time and a to time, so a from time and a to time. And then there's, of course, the input file as well. And then um, you specify copy because you don't want it to encode. You want it to copy. I believe you specify it through C. I don't remember though. I'll have to check what that command. Actually, I could check it here. Um, Wait a second. Okay, FFmpeg is not showing up here. Okay, I can't show the thing to you right now. However, just take my word for it. There's a flag that allows you to make it so FFmpeg is using a different method. Yeah, there's a different. Yeah, there's a flag that you can. Sorry, I was doing something. There's a flag that you can specify that makes it so FFmpeg is not re-encoding the new file that's being created. It's not re-encoding the video that you have extracted from this source video. It's mainly just copying frames. And like I mentioned before, there are some downsides to that. But this would be a good way for me to check out the video. Yeah, definitely. This would be, sorry, this would be a good way for me to check out the video because this extraction process would be super quick. It would be much, much quicker than re-encoding the entire video. And then once I find a clip that I like, I can do is I can give like I have indices, right, for each of the. I'm going to be assigning indices to um each of the entries here. So what I can do is I can additionally the file name would look something like, okay, the file name would look something like in order to show it to you guys, I could. Okay, I'll just do it on the next line. Okay, to FFmpeg. No, that's not. Sanitize. Sanitize file name, clip, title. Um, oh, wait. Yeah, this needs to be its own, like, separate print statement. Now I think we should be good. Yeah, so you can see some of the names here, or I could move to the next thing. In order to show this, I can probably come here and go into Zoxide, and where is the content pipeline? There. Right. So Python 3.13 py and run. This is our data. Um, I can scroll up and show you guys. Yeah. So you can notice you can see the title. It says find. It says finding the ESP32 Rust Goldmine, the ultimate learning resource, and then down here you can see the uh, the sanitized, quote unquote, sanitized version of that. It's a pretty long file name, but like I don't really care about the file names because these are supposed to be clips that I'm gonna eventually upload and then delete from my hard drive. So for the time being, them being, such massive file names is not really it's not really a big deal. Additionally, I can write some more logic in there to maybe add a length that if it's, so and so length, if the total length is, so and so, then reduce how many ever words from it and then set the file name. Okay, now my plan is at the beginning of these file names, I'll put the index number, the index number that we see. Actually, we don't see it here, but that's the index number that I plan to add to each of these. So in the first run, we'll extract all the clips using the copy method, which is the lazy method, which doesn't re-encode the video, but that does cause glitches. Once I've done that, then I'll run the encoding process because once I've done the lazy method, I'll have a bunch of clips to look at, and then I can select the clips that I like, and then once I've selected the clips that I like, I can encode those very specific clips before I decide to upload them. I feel like that would work out much better for me. And in this way, I can go through each of my VOD's transcripts and produce a bunch of clips to post over, the next couple of days. And I have a bunch of VODs. Like I I've started from the 27th, I believe. From the 27th of last month, because I believe that is when we started the. Is it last month? No, it was the month before that. So I think it's from the 27th of March, not from 27th of April. Either way, 27. I've started from there. That was basically when I had found this, quote unquote ESP32 Rust gold mine. I even called it that in the title. And holy shit, this has actually been a gold mine. Like finding this has been a real gold mine for me. We've had like quite a journey in terms of learning about how the ESP32 works, how no STD Rust programming for the ESP32 works, how various internals of the ESP32 work, and much more. It's been a it's been a fun journey, dude. Like it's been a very educational and informative journey. Sorry, zoned out. Okay. Um, Sorry, zoned out again. Right, right. Okay. Now, uh, I think that's about it for this the pipeline. Um, Yeah, I have my workflow down now, and after today's stream, I think I'll actually code out that entire workflow. It might need to be in two separate scripts, which is perfectly fine. I can have them as two separate scripts, and one of them will be, lazy extraction, and um, the other will be extract with encode. Yeah, yeah. The other will be extract with encode. And in fact, after the first extraction, after the lazy extraction, we are also going to rewrite the manifest file, the clip manifest file, to include indices, so that whenever we specify an index in the future, which is actually what we'll be specifying in the second script when we are passing, a file name. Oh, yeah, you know what? It's not going to be a file name. It's going to be an index that we pass in. So we're going to say extract. So one can be called lazy extract and the other can be called index extract. Yeah, yeah. Or I can call it extract by index. Yeah, yeah. Either way, let's continue. Let's continue with this. Okay, so we're gonna read about embassy and see what we are able to pick up to hopefully later apply it to the ESP32. Okay, there's a lot to learn here. There's actually, in addition to this, there's also this example that we were supposed to work on yesterday. Um, I didn't finish this because I there was a bunch of experimentation that I wanted to do, and I didn't manage to do that in time. Um, but yeah, that's in terms of embassy, the Impel Rust for ESP32 book doesn't really go too deep into it. I'm not sure why that is. I mean, yeah, I think I know why that is. It's because this book focuses on no STD Rust programming for the ESP32, so it doesn't want to um, go too deep into the details of like async programming. It's just going to introduce you to the concept of it, and then further on down the line, it has a bunch of much more. It has a lot more topics to explore, so that's probably why it hasn't really, gone too deep into that. I am curious though, in further examples, do they actually use um, async programming? Let's find out here. Where's the entire code? The entire code is here. Okay. Yeah, no. I don't think it's using. Also, main just says main. It's not the async macro. Yeah, yeah. Okay. So that's probably why, because async is one of those things that like it's its own subject. There's a lot to explore over there, but it's not like absolutely necessary. You can, like, if you have simpler stuff, which we are kind of looking at simpler stuff here, doing creating like a buzzer thing and working with the ultrasonic module. And oh, that dude, that'll be exciting, working with the ultrasonic module. Yeah, yeah, that's going to be interesting. That's definitely going to be interesting. But yeah, let's read this. Also, I need to check something. Okay. Sorry, zoned out. All right. Okay, Embassy book. Welcome to the Embassy book. Actually, while I'm reading this, I could probably expand the browser. Yeah, I could expand the browser and probably also pause this RTMP feed just so the fans don't continue crying. All right. Okay. Welcome to the Embassy book. The did I do the transition? No, I did not. I'm glad that I checked it. Okay. Welcome to the Embassy book. The Embassy book is for everyone who wants to use Embassy and understand how Embassy works. Introduction. Embassy is a project to make async/await a first-class option for embedded development. What is async? When handling I/O, software must call functions that block program execution until the I/O operation completes. When running, actually, yeah, now that I'm thinking about it, so like when we are writing async code, async Rust code, then or I should say when we are writing async Rust code for the PC, for the computer for x86, um, a lot of times we have this thing where it's like, okay, is your code CPU bound or IO bound? And depending on whether it's CPU bound or IO bound, you have to choose the right kind of async work, because not if it's IO bound, then you don't necessarily always need it to be offloaded to a different thread. You need to offload it to a different thread if it's CPU bound. So if it's CPU bound and the CPU actually has to do some other calculations, or some calculations, not some other, it has to do some calculations, you can offload this to another thread, and then whenever the CPU is able to schedule that thread to run, then it's going to run that, and it's not going to block your main thread, right? But if it's an IO bound application, or an IO bound operation, sorry, if it's an IO bound operation, then putting it on a different thread isn't necessarily going to speed things up, because the IO operation is going to take however long the hardware itself takes. Often, I/O operations have limitations due to the hardware. It could be anything, or anything other than CPU. So the limitation is something other than the fact that the CPU is not able to do the job quick enough. It could be that, if it's a file operation, maybe the hard drive is taking time. If it's a network operation, maybe the data hasn't arrived, or maybe the network hasn't process the data, or your network card, your socket hasn't received the data, or whatever networking related stuff. Either way, the data hasn't arrived at the socket, and the program is not ready with the data. So you don't want to block the main thread for that. You also aren't gonna benefit from offloading that to a different thread. You might as well, set it up as an async task on your main thread, and then let the Tokyo runtime, or whatever your async runtime is, let the runtime handle the whole, jumping between tasks and stuff like that. And that way you can have a bunch of tasks on the main thread itself. Okay, okay. Now back to this. When running inside of an OS such as Linux, such functions generally transfer control to the kernel so that another task, known as a thread, can be executed if available, or the CPU can be put to sleep until the task is ready. I feel like that's going to be one benefit on the ESP32, is the fact that we can actually put the task to sleep until sorry, put the CPU to sleep until the task is ready to execute. Until the task is finished, not even ready to execute. Until the task is finished, and then we can wake up the CPU again. So we have ways to conserve power. We have ways to save save up on, like, whatever power consumption we are doing. Uh where was I? Here. Because an OS cannot presume that threads will behave cooperatively, threads are relatively resource intensive and may be forcibly interrupted if they do not transfer control back to the kernel within an allotted time. If tasks could instead be presumed to behave cooperatively, it would be possible to create tasks that are almost free when compared to a traditional OS thread. There's also the fact that within, and I don't know how true this is for, Extensa and RISC-V processors, but at least when we are talking about x86 processors, when it comes to um, multi-threading, there's context switching that happens, and apparently that context switching does also take a certain, and I mean, to be fair, context switching also, I believe, happens um, in tasks, but I think in tasks it's done in a slightly different way than in threads. It's not done in the exact same way, at least on the thread side, because there's context switching going on, and context switching incurs a bit of overhead. So you kind of have to decide if whatever you are trying to offload to a different thread really needs to be offloaded to a different thread or not. Because if it doesn't, if it's small enough that you can keep it on the main thread and get away with it, or maybe even make it async, I guess, and get away with it, but then you decide to make it a separate thread, you might actually be um, having a performance loss instead of a performance gain, because your program might spend more time doing context switching than doing the actual work. Now, I don't know how true that is on the Extensa and RISC-V side. So on the ESP32 side, I'm not sure how that whole thing works. But this is what I've read when it comes to multi-threading stuff on the PC side, on the x86 side. Okay, continuing. In in other programming languages, these lightweight tasks are known as coroutines or Go routines. I've never heard that. Okay. In Rust, they are implemented with async. Async await works by transforming each async function into an object called a future. When a future blocks an IO, when a future blocks on IO, the future yields, and the scheduler, called an executor, can select a different future to execute. Okay, I kind of got that. I haven't actually gotten to the multi-threading side of, oh shit, I just remembered, dude, I was supposed to be learning Rust as well. I never finished learning Rust. The more advanced things, like, smart pointers and like bare bones multi-threading, and there were a couple more things. Actually, there were a lot of, like, fairly advanced things as well, but that's like way towards the end. Uh that's that's like that's like super towards the end, and that's really advanced stuff. That's creating macros essentially allow you to do code generation. So rather than having to write a bunch of boilerplate code, you can do procedural code. It's not even boilerplate at that point. It's just like, it's boilerplate code where you're going to need to change out certain parameters, certain parts of the code. And with macros, you can do something like that, because macros allow you to do code generation given, certain logic. And then there's the concept of FFI. I think it's called foreign function interface. FFI. It allows you to interact with external language libraries from Rust. So you can use something like C, C++ library and interact with Rust using, sorry, you can interface with that library from Rust. So in this way, you can use a library that has been written for another language, but you can use it in Rust. And I think they also teach you the other way around. So maybe creating a library that's written in Rust, but then being able to use it in something like Python, for example. I don't know if they cover that, but hopefully they cover that. Okay, all right. Compared to alternatives such as RTOS, async can yield better performance and low power consumption because the executor doesn't have to guess when a feature is ready to execute. However, program size may be higher than other alternatives, which may be a problem for certain space constrained devices with very low memory. On the devices Embassy supports, such as STM32 and NRF, memory is generally large enough to accommodate the modestly increased program size. Okay, what is Embassy? The Embassy project consists of several crates that you can use together or independently. So first you have the executor. The Embassy exec the Embassy exec The Embassy executor is an async slash await executor that generally executes a fixed number of tasks allocated at startup. It's an async await executor that generally executes a fixed number of tasks allocated at startup, though more can be added later. The executor may also provide a system timer that can use that you can use for both async and blocking delays. For less than 1 microsecond, blocking delays should be used because the cost of context switching is too high and the executor will be unable to provide accurate timing. Okay, okay. Sorry, I was just rereading that for a second because I was like, okay, wait. All right. Then, hardware abstraction layers. HALS implements safe Rust API, which let you use peripherals such as USART, UART, I2C, SPI, CAN, and USB without having to directly manipulate registers. Embassy provides implementations of both async and blocking APIs where it makes sense. Wait, this is interesting. So Embassy provides you with both async and blocking APIs. So like if I'm using Embassy over the ESP HAL, I'm assuming it's running on top of the ESP HAL and like interacting with the ESP HAL in some way. Um, then I'm guessing I wouldn't be using any like separate blocking functions. It's all going to be Embassy stuff. Regardless whether it's async or blocking, I'm going to be using Embassy's own APIs. I'm assuming that's the case. All right. Then wait, where was I? Embassy provides implementations of both async and blocking APIs where it makes sense. DMA is an example where async is a good fit, whereas GPIO states are better fit for a blocking API. Okay. Then embassy, the embassy project maintains the embassy project. Wait. Oh yeah, the embassy project maintains HALs for select hardware, but you can still use HALs from other projects with embassy. Okay, cool. A common question is if one of the embassy. A common question is if one can use the embassy HALs standalone. Yes, it is possible. There is no dependency on the executor within the HALs. You can even use them without async, as they implement both the embedded HAL, the embedded they implement both the embedded HAL blocking and async crates. Okay. Oh, okay. Yeah, they're going for. Wait, they mentioned LoRa here as well. Though, LoRa, um, I have modules for LoRa. I don't know kind of if this kind of applies to that as well or not. If it does, that would be great, definitely. Okay, networking. The Embassy network stack implements extensive networking functionality, including Ethernet, IP, um, TCP, TC. Oh my God, why am I having trouble reading? Ethernet, IP, TCP, UDP, ICMP, and DHCP. Async drastically simplifies managing timeouts and serving multiple connections concurrently. Several drivers for Wi-Fi and Ethernet chips can be found. Okay, then Bluetooth. The Trouble Crate provides a Bluetooth low energy host that runs on any microcontroller implementing the BT HCI traits. Currently, so and so, so and so, so and so. Oh, ESP32 is part of that as well. Great. Um, okay. The NRF soft device crate is for NRF52 microcontrollers. Okay, I'm not using that. I'm mainly using ESP32, so I'll stick with that for now. Okay, LoRa RS supports LoRa networking on a wide range of LoRa radios, fully integrated with a Rust LoRa WAN implementation. It provides four crates: LoRa PHY, LoRa modulation, LoRa encoding, and wait, LoRa LoRa PHY, LoRa modulation, LoRa WAN encoding, and LoRa WAN device, and basic examples for various development boards. It has support for STM so and so wireless microcontrollers or so and so so and so so and so. Okay. USB. Embassy USB implements a device-side USB stack. Implementations for common classes such as USB serial and USB HID are available. I think we use CDC, right? Um, like that's how the ESP32 is communicating with, at least, this one that uses a UART to USB chip. At least that's how this one communicates with the PC. It registers itself as a common device. I think CDC is common device class. I don't know. I don't know what the last C stands for, but the first thing is common. I think it's common device. Hold on. Let me look this up. USB CDC. Oh, sorry, it's not even common. I had that wrong. I only had device right. So, USB CDC is communications device class. Um, it's a standard protocol enabling USB devices to emulate serial communication, so virtual COM port. Yeah, that's what the ESP32 uses. It allows microcontrollers such as the ESP32, STM32, etc. to communicate with computers over USB without requiring specialized drivers appearing as standard RS232/UART ports. Key uses include USB to serial conversion, firmware flashing, and data transfer. All right. Then bootloader and DFU. I'm continuing. Words. Holy shit! I'm continuing reading this. Bootloader and DFU. ESB, ESB, Embassy. Embassy Boot is a lightweight bootloader supporting firmware application upgrades in a power fail-safe way with trial boots and rollbacks. I feel like I need to enlarge this. Yeah. Then DMA. For most I/O in embedded devices, the peripheral doesn't directly support transmission of multiple bytes at once, with CAN being a notable exception. Instead, the MCU must write each byte one at a time, and then wait until the peripheral is ready to send the next. For high I/O rates, this can pose a problem if the MCU must devote an increasing portion of its time handling each byte. The solution to this problem is to use the Direct Memory Access Controller. The Direct Memory Access Controller, or DMA, is a controller that is present in the MCU, is a controller that's present in MCUs that Embassy supports, including STM32 and NRF. The DMA allows the MCU to set up a transfer, either send or receive, and then wait for the transfer to complete. With DMA, once started, no MCU intervention is required until the transfer is complete, meaning that the MCU can perform other computation. I'm assuming by MCU, it's talking about the CPU here. Well, I mean, the MCU would include other things as well, but yeah. No, you know what? I don't think it's just talking about the CPU. I'm gonna say it's talking about the MCU, but then the DMA would be part of the MCU itself, right? It's part of the it's part of the what we would consider the microcontroller. So then I would have to assume that by MCU it's talking about the CPU, because then we are saying the CPU can perform other computation. Anyways, okay. Or set up other I/O while the transfer is in progress. For high I/O rates, DMA can cut the time that the MCU spends handling I/O by over half. However, because DMA is more complex to set up, it is less widely used in the embedded community. Embassy aims to change that by making DMA the first choice rather than the last. Using Embassy, there's no additional tuning required once I/O rates increase because your application is already set up to handle them. All right. Okay, we have an example here. Embassy provides examples for all HALs supported. You can find them in the examples folder. Okay, cool. So, okay. Wait, so here we have our main function. Okay, and we're setting up a logger here. I'm assuming this is mainly just for logging. And then here we have spawner. So spawner has been passed in here already. Spawner.spawn run.unwrap. And that is this. This is our task. And this says embassy executor main. So this is probably the main function um, the in the async runtime. And this is the task. So anything that's meant to be a task, I guess would be what do you call it? Giving it the task macro. Okay, embassy in the wild. Here are known examples of real world projects which make use of embassy. Feel free to add more. You know what? That's fine. That's great. For beginners. Let's read this. The articles in this section are primarily aimed at users new to Embassy, showing how to get started, how to structure your project, and other best practices. Getting started. So you want to try Embassy. Great. To get started, there are a few tools you need. This might be a problem. If it strictly requires probe RS, or maybe that's just an option. I think or maybe that's just a preference. I think we could still, like, in terms of flashing, I don't think it's going to be a problem because it's all part of the same binary, right? It's not a separate. The runtime is not a separate thing that's being exported, like separate from the binary. The entire the entire binary is still like one thing. So, or at least the blob that's being sent off is still one thing. So the thing that flashes that blob onto the ESP32, or the method that we use to flash that onto the ESP32, I think we can still decide that by ourselves. I think we'll stick with our thing because we don't have the option for probe RS, because I don't have, the ESP, I forgot what it's called, ESP programmer, ESP debugger, or something like that. Yeah, I don't have that. Though, to be fair, I would probably only need that. Okay, I was about to say that I would probably only need that with my older ESP32s, but then with the newer ones like the C3 Super Mini, I won't need that, at least for flashing. I don't, or at least I don't think so. I don't think I would need it for flashing. For debugging though, maybe I might still need it. I don't know. I should look into that. I should look into that. Yeah. Sorry, zoned out. Okay, so we have Rust up. We don't have ProbeRS. We're not going to be using ProbeRS. I don't know what flip link is. To link certain example binaries with Stack Overflow protection. Okay, that's fine. If you don't have any supported board, don't worry. You can also run Embassy on your PC using STD examples. That's good to know. Dude, that's good to know because this way we can practice Embassy stuff. Um, Wait, this has me curious. Okay, I'm gonna open up a new convo with Gemini. Hey, so I'm learning about Embassy to be able to do ESP32 no STD Rust projects using ESP HAL. This has me curious about whether I can use Embassy on PC as well, um, just for the sake of practicing, um, but even otherwise similar to Tokyo. Okay, yes, you absolutely can. In fact, Embassy on a PC is a great way to practice the async/await mechanics without needing to constantly flash a microcontroller. You know what? Yep, that is definitely an appealing thing. That is definitely something that would make me consider doing it on the PC. While Tokyo is designed for high performance servers with multi threaded scheduling and complex I/O, Embassy is designed for efficiency and predictability. How to run Embassy on the PC. The Embassy Executor Crate has a feature flag specifically for this called Arch STD or Platform STD, depending on the version. When you enable this, the executor uses standard OS threads and mutexes under the hood rather than raw hardware interrupts. All right, okay. Dude, you know what? This is great because I have been meaning to get into async programming. And now I think through Embassy, instead of Tokyo, we can keep Tokyo aside for a second. Instead of um, instead of Tokyo, through Embassy, I could learn async programming. Though I'd imagine whenever I'm trying to do async stuff in other frameworks, like let's say I'm doing Ratatouille, for example, um, I would need to see if it is async compatible or if it's specifically Tokyo compatible. Because if it's specifically Tokyo compatible, then I would be limited to, you know, having to use Tokyo. But if it's async compatible, then I would be able to just use Embassy. I should do more research on like the differences between, Embassy and Tokyo here. Oh, actually, there's another section down here. Embassy versus Tokyo. Even on PC, Embassy feels very different from Tokyo because of its core philosophy. Um, so there's a list of features mentioned. Can I just copy this entire table? What would that look like? Oh, actually, I froze the RTMP feed, so you guys won't be able to see it. But I didn't freeze it so that you guys can't see it. But because I froze it, that's why you guys won't be able to see it. Um, I can just read it. I can read it out. So they've given a table. They've given a couple of features: allocation, scheduling, complexity, and timer. So on Embassy, in terms of allocation, you have zero alloc. Tasks are usually pre-allocated in a static arena, quote unquote arena. And in Tokyo, it's dynamic. Tasks are spawned on the heap. Then in terms of scheduling, Embassy has cooperative scheduling. I don't know what that means. One task can block the whole executor if it doesn't dot await. Okay. But for Tokyo, in terms of scheduling, you have the concept of work stealing. So it can move tasks between threads if one is busy. Then complexity. Embassy is extremely lightweight and it fits in a few KB. But Tokyo is heavyweight. It includes complex features like I/O drivers and signal handling. Then for timers, you have simple global clock via Embassy Time. And for Tokyo, you have high resolution timers with complex wake up logic. Okay, you know what? Maybe I should spend some time learning Tokyo as well because it seems like Tokyo would be used a lot more on stuff that's meant for the PC. So I don't think I should be pushing Tokyo aside. Yeah, yeah. Though that being said, we've made some good progress today. Definitely made a bunch of we made good progress today. We're going to continue this. We're not done. We are nowhere near, you know, being past beginner um, status, beginner level. We are nowhere near past beginner level. There's still a lot that we have to learn. Give me a second here. Okay, we cannot do that. That sucks. We can do this, but then I can't see anything here. So that sucks as well. Here's what we'll do. Um, Wait, this is interesting. We cannot do that. Okay, great. Awesome. And there's somebody here who very much looks like Shaq. Oh my God. Oh my God. Okay, that was that was just a thumbnail. But no, even right now on the stream, this person, dude, the thumbnail, if you guys could see the thumbnail, it very much looks like Shaq, as in the basketball player. Okay, I'm still looking. Okay, we'll try this. We cannot do that. Okay, let's try this. And I believe we can do this. Okay, cool. So let's try running the raid and see if they have any like settings or something that prevents a raid. No, they don't. So this is a person who's doing artwork or something. We're gonna go hang out in their stream. But yeah, dude, that's gonna be it for today's stream. And an ad just started. Holy shit. Anyways, that's gonna be it for today's stream. We made some good progress today. We definitely learned some embassy stuff. I think I need to chill with the Yap session at the beginning of this. I mean, it's not so bad really because even the Yap session was it's part of the stream, so like it's not really that much of a problem. I don't think I need to chill with it. Yeah, I don't know why I said that. It's just that it took time away from this embassy stuff that we could have been doing, and honestly, if I had started the stream earlier, then I would have gotten a lot more time. I could have yapped for a bunch of time, and then I could have done the embassy stuff for a bunch of time, and yeah, we would have continued learning. But I guess we'll need to start this tomorrow or continue this tomorrow. And now off stream, I'm gonna continue working on the content pipeline, and I'm gonna try and make as much progress as possible, and I'll report back tomorrow. So that's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.